So there's no reason to talk about graphing. Think about it. The only time you have to worry about graphing really is if it asks you to find an asymptote, something like that, find an intercept. You can do that all in the calculator, really. I think the tricky part with the graphing might come back in with some of the trig stuff. We'll review how that goes because you might have to find your intercept or something like that, or period, bless you, your period or amplitude, things like that. But when you're talking about logarithms, exponential growth, those types of things, those graphs are ridiculously simple to worry about because you've got a y equals button. So you shouldn't have to worry about that. Okay.
Help us figure out, do we need to be able to tell which one's which?
Exponential growth and decay, the difference between the two is the b value. Remember, you talk about exponential growth or decay. That b value, whether it's with shift or not, is what tells you whether it's growth or decay. It's growth when b, this b is greater than 1, and it's decay when it's between 0 and 1.
Oh.
That's the difference. Yes, ma'am.
I was watching the video last night, and I'm confused on what the difference between A represents and B represents because
A is a scalar.
Okay.
That's all it is. It's just scalar multiplier. That's all it is.
Okay.
It changes the intercept races. That's really all it is. So yeah, graph-wise, pretty straightforward. What I want to look at though is some of the real fast. Which one was it?
It's really cold.
Solving the equation stuff. What's that?
I said it's really cold in here.
Same temperature as it always is.
Yeah.
No, it's cold.
Don't you see he has a hockey jersey on? Finding nickel.
No, same temp.
66.6?
No, it's 67.1.
What?
It's cold. It's like 42.
So how do you solve for x?
Wait, what number? Oh, you move them around? Yeah.
No.
Oh wait,
You
wait,
exponentiate it.
Yes,
Oh,
that's
E
what I
it.
meant.
Oh no. Okay.
So E is for like the LN, right?
Right.
Oh, that's like.
Now, when you start looking through stuff like this, remember when you're solving for equations dealing with logarithms or any of those, you have your properties of logs that help you solve them. You have to remember that b to the log base b of x equals 1, or excuse me, equals x, and log base b of b equals 1. Isn't that it?
Yes.
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 Because log b of 1 equals b.
Correct. Those are a couple of little properties that we dealt with logarithm. Also, you have a calculator. Can't you hit the log base button on there and plug and chug if you forgot how to do problems?
Wait, where's the log?
Alpha window. Alpha window 5.
But we weren't allowed to use the word plug.
Oh, you're not, but I just said it.
It's okay.
We'll make sure it'll catch.
Is there,
How do you get the same one?
is the final pretty evenly split between everything we learned this year? There's 5 questions for this, 5 questions for that. Is there a thing that there's a lot of stuff on? Is there a lot of trig? Is there a lot of probability?
You know, I haven't really counted it. I think it's pretty evenly dispersed. If anything, excuse me, if anything, I'd almost assume there would probably be more trig than anything.
Yeah.
And it wasn't like it was to be that much more, but we did much more stuff with trig than we did the other stuff. If you think about it.
Yeah, we spent a lot of time. Is there going to be a lot of modeling?
I don't even remember mine.
In order to solve this equation, you actually have to condense first. This is the trickiest one, I think, on the solving stuff. So you have to condense the logarithm. Now, there's one of two ways of doing this. When you're worried about condensing logarithms, you're trying to take these two guys and make them a singular log. Well, this becomes log base 5 of x squared over 2. Using the properties of expand and condense for logarithms, when you have a number out in front of a log, it's the exponent. When you have subtraction between the two, it means division. If you had addition between the two, it meant multiplication. What?
I'm confused on how you get the x over 2.
Because it's subtraction. I just said with subtraction, it means division.
If it's,
That's what that means.
if it's addition, does it mean multiple?
Yep. So the properties of that were when you're subtracting between two of the same log bases, it means dividing between the two values. Now, one of two things you can do. You can remember how to set that up, and you wind up with log base 5 of x squared over 2 is log base 5 of 2x plus 6. And you'll notice that they have the same log base, so what basically happens here? You would exponentiate them both, and they would just drop where you get x squared over 2 is your 2x plus 6. So you get x squared minus 4x minus 12, and you got a factor. You have zeros at 6 and negative 2, and one of those might be extraneous and we substitute back in. Now, if you forgot how to do all of that, you still have a calculator. You still have an alpha window number 5 button. You can get a decimal equivalency of log base 2. So if you had to do a log base 2 because you don't remember how to do condense, not a big deal. Oops. Here's what you can do. I'd move this over because that's a crummy number. Log base 5 of 2 is a crummy number. Bring the other one over. So you have 2 log base 5 of x minus log base 5 of 2x plus 6 is log base 5 of 2. Plug and chug. Yeah.
Could you just write down, like, because I know you like skip the basic math of it, because I get that the minusing it is.
Minus means division, adding means multiply.
I know, and I'm getting lost in how you combine.
When you have things subtract between the two, it just means you divide the second term. If there was an addition side between the two, you multiply. That's all it means.
What do you mean divide the second term?
What's the second term? What's the second log?
So you just mean
Yeah.
you ignore the log 5 and you
Yeah.
divide.
When they're the conditional, when they're the same, that's the properties, when they have the same log base, you can do those
Okay,
things.
that's what I was.
Wait,
Okay.
what?
Okay. The other one that was like that people have been asking about, where was it? It's the same idea when you're looking at these guys, when you're expanding and condensing. On the other sheet. So if you're expanding and condensing here, if it's telling you expand that into multiple logarithms, you've got 3 terms there, so you should have 3 logs. Since you're multiplying between the two, you're going to have addition. We did. And you just drop the 2 in front of the log for the, yes? Okay. Go in the other direction, you've got, again, since you have the same log base, you're just dividing these 2 terms. It's log base 3 of x to the 4th, oops, divided by y to the 16th. That's all that those properties meant. Yeah, but I used your name. You see that hand
I
up?
was gonna say
That was weird, actually. Freaked me out. Can we do number 17 on this package?
Which one?
This one. The chapter
On
text
number
meeting.
9, is that the actual answer?
Yeah.
That's like the full answer?
Yep. Just all you do is expand. You're not solving for anything.
Wait, is
This one is solve the equation 10 to the 4x minus 1 is 1,000. This is forcing you to get the same log base. How do you rewrite 1,000 as base 10? Yeah. Do they have the same base?
Yeah.
So if you log both sides, log base 10 of both sides, they drop, you just get 4x.
Minus 1 equals
Did you say this one's 17?
this is on a different?
Okay.
Oh, wait, oh, I found it. Wait, leave it up again.
So basically, when you log base something, you just, and they have the same base, you just take over.
Yep.
You don't have
Same,
to leave it up.
yeah, and then if you look at 18, you've got 2e to the x minus 1 is 9. add 1 divided by 2, you get e to the x is 5. And then how do you undo e?
Natural log.
Natural log. Undoing e,
So
you
that would-
natural log, which is log base e. Sir.
So then we have like x equals natural log 5.
Yep, that's your answer.
And then you don't solve for that.
Well, whatever, it might be a decimal.
Yeah.
That's all it
You
is.
just have to look at the answers.
So you check for extraneous solutions.
Does it work?
Okay.
We'll be able to hold on to our package over the weekend, right?
No, I'm gonna keep it. I'm gonna take it from you. I don't want you to study.
Oh. You're not collecting these before. Thanks.
Our Spanish teacher collects.
Seriously, it's
You
All the answers are in the back of the packet.
I have all the answers. It's just kind of like, I mean,
Same with Spanish.
I just kind of give you guys problems to do and do them. You know, and it's up to you to try, it's up to you to study it out.
Ooh, you should give us extra credit.
People have asked me on the chapter 8 test stuff one about numbers 22 and 23. Don't even bother with it. I'm never going to have you guys ever worry about getting a decimal equivalent, use a decimal equivalent to solve something. That's just downright stupid. Use the button on your calculator. The other one is talking about, what we have here, inverses. Remember how you find an inverse? This is 21 on this one. So it's y equals the log base 7 of x.
Don't
When
you
you-
move it around?
You move them around. Okay, so let's move them around. Woo! Woo! Let's bounce it.
21.
Exchange x and y and resolve for y. So how do I solve for y in this case? Buongiorno! How are you?
Good. I need Ben Allen just for 2 seconds.
Mr. Allen, you're in trouble.
Hustle up, brother. Take a second.
How do you undo it? Nope. Nope. Exponentiate. Very good.
Wait, what is that? You just use the base.
Yep. Exponentiate with the base. 7 to the log base 7 allows the y to
I
drop.
forgot that exponentiating was a thing.
And that's your inverse.
It's a cool thing, isn't it?
That's your inverse.
Yes, sir. That is your
I
inverse.
don't even remember what was at all. What was I doing?
Were you whittling?
Can we do like these other solving?
Oh, I did it.
Wow, that hovered bucket for a little while there, Naria. Woo! On the other packet, there are some other inverses. I don't know.
It's just here. I don't know how to do it.
Which number was it?
15 and 16.
Yeah, 15 and 16. I'll do 16. They're the same. It's so simple.
What was it?
I tried.
I like looked at it.
So remember, change them. X equals 3 to the y plus 2. Subtract 2.
Yes. Then do.
Now what do you do to get the y down?
Log it.
I have to log base it. This time I log base. Because if I log base over here, it just becomes y.
Why do you usually log those?
Because that's
But then don't you have
the point of it.
a log 3 over there then?
I do.
What do you
My answer here is this, Trish. This is my answer.
Equals
Can we do these like solve each equations?
I'll get there. On the other one, flip-flop them around. So x equals e to the y plus 10. Subtract 10, and then how do you undo? Then you natural log it.
What number does it?
2.7 something, I think.
2.7. Wait, why did you ask if you knew? I was just
What were we talking about? Are you looking at the solve the equations on that
Well,
page?
these and these.
Oh, the top one. I love that top question. I love that question. When you're solving equations with these, they are forcing you to rewrite them in the same base. So on number 5, it's trying to force you to rewrite all of the numbers as base 5s.
I don't know, so.
What is it, 5 to the
I don't know.
-4? Very good.
I didn't know what the exponent was.
Oh, to get one over.
Thank you. So 1 over 625 is 1 over 5 to the 4th. So I rewrite that as 5 to the -4th. The denominator of 5 to the 3x is the same thing as in the numerator, 5 to the -3x. And now the numbers on the left, do they have the same base? Are you multiplying? What do I do with the exponents? I add them together, and then I will drop them down. Since I have the same base with different exponents, I do log base 5 with both sides, and I can set them equal to each other. Okay. The idea here is that you're trying to get the same exponent.
You do all those five.
Yeah, but in this case, you just set the two exponents equal to each other, you'll be fine. You should get
Because they're both
-6.
sides.
Yeah, it's really fast. In 6, it's forcing you to write in the same base of 2. It wants you to do base 2. Because what 16 can be broken down as 4 and 4, which is 2 times 2 times 2 times 2, so it's 2 to the 4th. 64 is 8 and 8, which is 2, 2, 2, 2, 2, and 2. So what happens here is you wind up with 2 to the 4th times 3x equals 2 to the 6th times 2x. Once again, since you've got the same base, different exponents, you can just drop the exponent because you're technically log base 2 of both sides, so it works. And you wind up with 12x equals 12x.
So x equals, what even is that? Just like everything?
X equals everything, so it equals all real numbers. When you get to something like that, that is your all real numbers solution because it's a valid statement. Yes, ma'am.
Do you have to use like all, like, because I used 4.
4 does work because you can still get in the same base. But sometimes you'll get it where you'll have like a 9 and a 27, where you have to go all the way to 3. 2s are nice because 4 work too. And you had 4, then you wound up with what? 6x to both sides? That's fine. Because if I divided both sides there by 2, what do I get? Yeah.
Which one do you keep? All of them.
Yeah. Yes, ma'am. You want to help me? Don't scowl at me. You saw that. On that, which 13?
The one you gave us yesterday.
We should give these each name so we know.
Yes, like, this is the yesterday packet.
What about tomorrow? What do
You call it the Tuesday packet.
Tuesday morning never looked so good. Isn't your test on Tuesday?
Wednesday.
Oh, it'd be so much better if it was Tuesday, because Tuesday, that's a great song.
Wednesday, there's gotta be a Wednesday song.
But on
somewhere.
Wednesday, we can say Tuesday's gone. Like the wind.
Yeah, you have a choice.
All right, so add half, divide by a -4. You wind up with 14 to the 6x plus 1 equals 11.5 over -4. Not a nice number.
Wait, no, because it's a negative 1.5, so it's
It would just be
positive.
positive.
Thank you.
I was gonna say.
So let's see, half of that would be something. I don't know, whatever. So in this case here, how do I drop the exponent? Log base 14. So 6x plus 1 is the log, it is gross. Log base 14 of 11.5 over 4. So then I just subtract 1 and divide all that by 6. And you get some really, really ugly number.
Gross.
Gross.
No, it's because it has, like, it has like the same That's just negative 0.1.
What does it even end up being? What if it was like,
The answer is 2.
it's negative 0.1, that's not even that bad. Did you make this package?
Yeah, I press button on my computer.
Huh. Really?
I told you, I have a button. It's really cool.
Whoa, 14 is like easy.
Infinite
like
Algebra 2
pretty.
site license?
Uh-huh.
15 is easy.
All he wants is a kayak. I pick stuff and I make stuff. You want to learn about radical functions? You pick hard questions.
Oh, I love park.
And it is
Make
generates.
your test.
Just do a
Just
log
go
one
hard.
half, right?
Just make stuff. Stuff that made you
Let's see what else we got on this I wanted to look at. When you do the solve equations on here, it's the same basic idea. You'll have to just work your way backwards off of the logarithm stuff, so it shouldn't be so bad. For example, if I look at number, let's do 20. Add 7, divide by -2, and then take your log base. So this one here, subtract 2, divide by 7.
So 1. It's space 10, right?
It's base 10, so you just,
Oh, just assume that it's not there. Thank you, I forgot.
Wait, what?
You moved it over.
I subtract 2, divide by 7.
Oh,
I mathed it.
what? Do you subtract the 2?
That's a cool shot.
What is? Oh, I love watching clouds do that.
I like it when you see airplane shots. I think that's cool. Look at a duck.
I like our stuff.
Yesterday we were doing this one drama school for gym. And Sierra was like, I just all these ducks. And she's going over being dead. And she's like, you can tell me this. I didn't know about it. Yeah, it's in the pond. And she was like, it's definitely made of duck. I'm like, are you positive? And she was like, yeah, no doubt about it.
Sorry, I was making that conversation now.
Okay, bye.
What was that?
Fell about. What's wrong?
14.
Maggie, I'm on.
On this one?
Yes. My calculators are error, so unless they're broken some rule, I forgot about it.
-30 divided by -2 is 15.
So you just divide by negative.
Oh crap, did I just do that? Oh, you have to divide it by -1 first.
Oh.
So what happens here, this is a -1 times the 2.
Okay.
The trick on that one is, because you can't take a log base of a negative, you have to take the -1 out of it. Because that would be the A value of the -1, B is the 2. Then you just log base 2 of it.
I'm trying to like move around to get warm and it's not working. I'm really cold right now. Sounds like I told you before. Your face seems like a huge. Oh my God.
Oh, flames. Keep going.
You down? I will say.
Now she's dying.
Oh no.
Wait, how does the answer?
Well, I have a question for you. Come in here. If there was one thing you had to go back to your old self, and it was so long ago, and tell yourself that you had to remember from Algebra 2 to get the pre-calc, what would it be?
I don't really remember anything still, so probably, oh man. Probably those, triangle, sine, cosine.
Drink.
That's what I'd say, because I still don't know that. So, yeah. Yeah, I think so. Can we get Hunter in here too? Can you give his opinion?
Yeah.
Triangle stuff.
The triangle stuff. So speaking of triangle stuff, let's switch into the trig.
Okay.
Trig stuff was chapters 13 and 14. If you think about it, I'm pretty sure this is the stuff that we spent bulk of our time on. As you go through the trig stuff, the first chunk of it was all about SOHCAHTOA, 36 and 90s.
Thank you.
Oh, is it one, two?
Yeah.
And then it's across from 6 to
You also had good old-fashioned radians and degrees.
Oh, I was doing that like part of the packet today, and it was way easier than I remembered. Like, I don't know why it's
If you think about it, you need a lot of practice to get good at that. What
No, I
happens-
got it like 7 times in a row.
I did the marching without messing up with 5.
Why do you throw it so high?
I don't know, it just happened.
I thought you
Hard to like out to like a small object.
I just go with an
It's so much harder than a pencil.
Well, if you go like.
Parker, come here for a second.
It's gonna stab me. So
Yeah, good to see you.
Hi.
Same.
I don't know, but hi.
If there's one thing you can go back and tell your old self in honors last year, what would you tell yourself to remember that was really important for pre-calc?
First of all, it's important that it's June. Second of all, I don't know, don't kill puppies. That was a comment.
Common thing. Let's go public to a crowd.
Trying.
Those were important, right?
Yeah. It's hard.
What are you guys doing?
Don't take pre-calc. Nah. No, do they know the unit circle? Remember that.
Woo!
Okay. There's my knowledge.
Thank you.
Jack told me to come and it didn't go too well.
Thank you. You get the door. Appreciate it. Ask Lena to come here.
Wait, just ask the whole class.
You catch
One
it.
time, like, just send it. Here we go. Sounds better than
You can actually wave like this.
Woo!
I don't believe it.
I could have seen it.
Anyway, so what I want to look at here real quick is on the Friday
packet.
packet.
Yeah. Oh, I like
Monday, I don't remember.
I hate the Friday packet. I like the
Obviously, the first couple of questions are all about solving for angles. You need to make sure that when you're solving for angles within a triangle, that your answer is in your calculator is in degrees. Come here for a second. If there was one thing you could tell yourself from last year that you really, really needed to remember for this year, what would it be?
Unit circle?
Oh,
Okay. Wait, that.
2/3 of me already said that. I've only had 3 people, so.
Yeah, unit circle. SOHCAHTOA.
Everything else is easy.
Yeah. So basically, none of this matters. I mean, you're gonna do it all next year, then. Oh.
everything.
Logarithms.
They are fun.
They're easy, especially the exponentiate. I don't know. I look like a little kind of boring.
I mean, I Hunter was just like, "Please tell me if you want to teach on." I thought he was lying.
What's in bed?
She'll probably say the same thing.
All right.
I That's all I remember from last year, to be honest.
It's gonna beat you in the head with it.
Yeah, get back together.
We had a conversation.
It was nice.
And then you go just reach it.
That was hard.
So good telling. Oh, yes.
You guys want to change the mode in your calculator?
Oh, yeah.
You press the button that says mode. Wow. Convenient.
Get a little wild.
You want to change your mode if you're solving for angles within a triangle?
You want to go into 3?
Wait, so,
Degree.
with it like, when,
Do you need it in radian the rest of the time?
Not really, I mean, because, well, most of the stuff you guys did with radians, you didn't get a calculator anyway, so it'd be kind of weird if you have to solve using radians.
That's how keep it on.
Right. So, what I want to look, yes, sir?
so like when you have, does it just give you like the answer in pi?
Yeah, it's going to give you a pi value, but it's not going to be anything equivalent to what your customer's seeing. Yeah, it's going to give you some really awful values. What I want to look at here real quick is number 20. And it's going to ask you to solve the triangle. Which means you have to find the two sides and an angle.
The angle is 80.
How much?
120. 120.
Okay.
60.
That should be 60.
Why is that wrong?
The 20 should be 60.
Yeah.
Oh, I wrote it down wrong, that's why.
Yeah, I was like, what are you guys talking about?
Oh, yeah. See?
No, it's fine. Sorry, I wrote it down wrong. Sue me.
That's so confusing.
So, in this case here, how are you going to find your missing side length since it's not a right triangle? Cosines isn't going to work as clean for this one.
We have to do like,
Sine.
Long sides. Choose long sides. It says you have the angle and its side opposite. Choose law sines. And then just go sine of b, or to be sine of 60 over little b. And then it's just a whole lot of cross multiplying itself. Okay.
I forgot all about this.
Now, what happens when you do have law of sines? What was the nasty thing that had the possible happening? You can get a wrong number, but you could also have two triangles.
Why do these things have to happen?
let's just go through.
If you look at number 21, it gives you angle C at 40 degrees. Little a is 10 and little b is 20. This is your side angle side scenario. This is the case in which you have to use law of cosines to solve. It is going to force you to find which side length first. Little c. It's going to force you to find little c first because law of cosines says c squared is a squared plus b squared minus 2ab cosine of angle c.
I do not remember.
Is there going to be an equation sheet of any kind?
I do not believe so.
Nice. Nice. I don't know what I did to you to deserve that, but it's not
Hey, when we speak stuff, you know it's serious.
I'll
No, really, what happened?
No, the one that makes all your tests.
Oh, that one? So c is going to equal the square root of 10 squared plus 20 squared minus 2 times 10 times 20 times the cosine of 40. And I will walk you through how you set this up to double check whether or not you do get
Isn't there
a secondary triangle.
Is there an equation like that for everything? Where does square root come from? What is this? What is c squared? What? I am a little frazzled. This is the only important final I have left, and I'm freaking out about it. Yeah, I know. That's just 5 days to freak out.
No, I didn't want that.
So you're a little hot. So this whole girl will be dry. You can't shoot it.
What? I just typed all that in and nothing showed up. I don't even know what I would give you guys.
Like this?
Just write a log code.
Just remember, the cab. I lost it. You know, I can't even try. Cats always burn two. Wait, cats always burn two. We want to remember it.
So I'm getting a side C of 19.31.
That's
Or 13.91 for those of you that are not dyslexic. All right, now it's going to force you to be able to use log signs now to find the next angle. Hold on, guys. In this case here, it's going to tell you to find which angle first.
A. B.
You got to find A or B
Who really
first.
cares? It doesn't matter.
It does matter.
B.
Is it B because it's the bigger number?
B, if you look at this triangle, is going to have to be the largest of the three angles.
And if it's not, there's no triangle.
Oh, yeah.
So you only need to use the log cosines when you have two sides and an angle.
Right. So using some math, sine of 40, would actually be 20 sine 40 divided by 13.91,
You get a 29.
second sine of my answer. It's giving me an angle of 67.55.
That could work.
So B would be 67.55, which means angle C would just be the leftover. Okay. What is that going to be? 107.55, so it'll be 80. Oh, sorry, 72.45.
Yep.
Is that possible?
That's not
No.
possible.
Why?
Because 72.45 is across from
Has to be
10.
the bigger one.
It's bigger.
Yeah.
So we just say the wrong.
Well,
that rule again? That says that the biggest angle always wins the biggest side.
I don't remember the actual. I think it's called the triangle inequality theorem.
I mean, I know what it is. I know what it is.
I think that's what that's called. But remember, B could also, there's also a different value for B, just to double check. The trick was when you dealt with the ambiguous case, is that you always checked its supplement. So the supplement to 67.55 is 112.45.
That could work.
Now, if I look at that with 112.45, my original angle of C was 40. There's still enough degree value left to get me to A.
Yeah. So,
So in this case, A could be, what was it, 27? So this triangle, does that work?
yeah.
That one does work because this one, the value doesn't work through.
So what did you do?
Supplement.
That's why I love it.
Check the supplement and then you add it to whatever the given angle was to see if there's enough degrees left.
Always have to check.
I would.
I'm so glad we get to review for so many days.
Wow. This was probably the trickiest stuff of that first grouping of chapter 13, really, was that ambiguous case of law, sign, law, cosine. But also, just think about the amount of time it just took to do that with an ambiguous case. Bad.
Same. That's
Is
how I
it
feel.
from Austin Powers? Sound like Austin Powers.
I thought you were gonna say Austin Freeman at first.
What the heck is that?
After that, we start talking a little bit about coterminality.
Oh, yeah, that was easy.
When we got into coterminality, I think the first, one of the questions you had there was write a positive and a negative coterminal angle to negative 13 pi over 4.
You draw the thing.
You draw the thing.
And you get negative 5 pi over 4 and 3 pi.
Why did you wuss out? Oh, well, that was, you were singing my song.
That would have been good.
What was the song? One letter.
That was kind of off kilter. It wasn't as good.
Look at that.
There it is.
It's gonna hurt for a while.
Ready? 1 little, 2 little, 3 little pies, and a quarter total pie. And I know it's 3 pi because 4 goes into 13 3 times, there's a quarter left. Which gives me a positive at 3/4 pi.
Oh god, I hate this thing. I don't understand why that's positive.
Wait, where is it?
Like why you go all the way across and you don't do that in the other
So
side.
this is negative direction.
Yeah.
This is positive direction.
Well, yeah, but like why do you go from one thing to the other?
You went the wrong way. Wait.
No, he didn't.
No.
And it's weird because when you tighten a screw, it's righty-tighty, lefty-loosey. So righty-tighty, if you're tightening the screw, you're going around this way, which is a negative direction. But if you're loosening the screw, you're spinning it out a positive
No,
direction.
this has always messed with me because you know you're going righty-tighty, lefty-loosey, but are you talking about what direction it's going on the top of the circle or the bottom of the circle?
What?
You know what I mean? Like look at it this way. Okay, this has messed with me since I was like 8. When you're going to the right or to the left, you know.
Which is it? Right or left?
Well, you're going this way, right? Okay, up here you're going left, and down here you're going right. And up here you're going left, and down here you're going right.
Yeah. I get
And then when you're going the other way, which I can't figure out which way that is right now. Okay, you're going right up here and left down here, and right up here and left down here.
It's the initial spin.
Okay, whatever. But this has messed with me since I was like 8.
The
I'm not like
initial,
turning lefty loosey. I'm like, which way is lefty?
the initial spin.
I tried both ways. Oh, I had those problems. Yeah, seriously.
You know, to an 8-year-old, it makes no sense.
So try and do that when you're working on a car. If you're working on a car, it's
Well, I mean, you can tell when you're
looking. The
doing
bolt is in front of you, and your hand is here, and you have to go righty-tighty. It's actually lefty-loosey as you're looking at it.
I don't
You're
think about
back-
righty-tighty. I think about clockwise and counterclockwise. That makes so much more sense.
Real fast though, here, the people have asked about the negative. Whenever you're doing positive and negative coterminal angles, you're always going to be within one revolution, plus or minus 2 pi. So basically, you're just going to subtract 2 pi out of, or excuse me, since it's past 2 pi negative, add in a 2 pi, you're still going to have a negative angle. So your negative 2 pi would just be coming up here. So that would be negative pi plus 1/4, so it would be negative 5 pi. We will continue our discussion on trig, all things trig tomorrow. Try and get through as much as we can. Hooray for trig!
Hooray for math class being over.
If you were in Minocqua and you had to go get groceries, you'd have to go to Trig's.
Okay.
It's a grocery store. I love Trig's. Trig's is awesome. They sell Landjaeger beef jerky. It's so good.
I love beef jerky. It's so good.